Alright, this video is going to talk about right triangle trig ratios, or trig ratios that are related to right triangles. It's not a super in-depth part of trig, but it's a great place to start. There's a ton of trig out there that's related to circles and all kinds of good stuff. But for this purpose, we're going to keep it kind of simple because it's a weird-ish topic if you haven't seen it before. But it's pretty amazing, actually. It's got tons of applications out in the real world. So before I start fiddling around with that right triangle there, I want to teach you what the ratios are, and I'm going to have to fill in a little bit about what that means. So here's one trig ratio. We call it the sine. Another one is called the cosine. And the other one is called the tangent. Alright, the sine, we have an abbreviation for it. It's called the sin. People like to say sin, but it's actually sine. The cosine we abbreviate as cos. And the tangent, this one makes sense, we just abbreviate as tan. Each of these ratios have an equation, or I guess you could maybe call it a formula. For the sine, we would say that the sine of some angle is going to equal the opposite over the hypotenuse. Hypotenuse should sound a little familiar, the opposite might not, and we're going to talk about that in just a second. The equation or formula for cosine is this. The cosine of an angle is going to equal the adjacent over the hypotenuse. And I'll write those words down in just a second. The third one, the tangent of an angle, that is going to equal our opposite over the adjacent. These, I'm going to change colors. These three here on this side, those are your ratios. Ratio is an intimidating sounding word. It really just means a fraction, which is also intimidating, or it can mean like dividing two numbers. So don't panic when you hear trig ratio. Okay, let's talk about opposite and adjacent. When you are going to talk about labeling the triangle up using the words adjacent, opposite, and hypotenuse, you want to remember that it's based on a reference angle. So if we look at our picture here that I've already drawn in, the only angle we have is this. That indicates it's a 90-degree angle, which causes it to be a right triangle. And that helps us, if you can always find the 90-degree angle, straight across is always your hypotenuse. So label that up as soon as you see a right triangle. Put a label on it, H or hypotenuse or whatever you want to put. That means we still have the adjacent and the opposite. I'm just going to write those down in case you're taking notes. Adjacent, our opposite side, and adjacent side. When I go to do these types of problems and I see a right triangle, I label my hypotenuse first because it's super easy to find. Then I go and label the opposite side next because that is also easy to find. However, the picture I have up here does not let me know which one's the opposite side. If you listen to what I said a minute ago, what I'm missing is an angle measure. I need a reference angle. So let's say that this is 32 degrees. So this is my reference angle. The opposite and adjacent are based on the reference angle. Alright, that's super important. Based on the reference angle. Okay, so let's look at our 32-degree angle up here. If I want to find the side opposite it, it's just kind of like finding the hypotenuse. I start at the 32, go straight out, bump into a wall, and that one there is the opposite side. And again, I find the hypotenuse and opposite first, because it's basically the same sort of maneuver to find it, and that leaves one side left open, and it has to be the adjacent. And the word adjacent actually means next to, and you can see that the 32 is actually next to that side, so we're good to go. Okay, I am running out of space here, so before I switch screens, I just want to look at this. I'm going to rewrite this on the next screen, and it takes up a lot of space. So here is a shortcut, and maybe you've heard this, I don't know, but here's a shortcut. It sounds like an Indian tribe when you pronounce it out loud. Sogatoa, kind of is an easy thing to remember because it sounds so unique, but it helps us remember that our sine is the opposite in the hypotenuse, just like here. Our cosine is the adjacent in the hypotenuse, just like here, and the tangent is the opposite over adjacent. So it's a lot more shortened version of this big whole box. So let's get this stuff out of the way and let's start fresh with this triangle. Alright, I said this was 33. And let's say that we know that this here is 12. We had that labeled the hypotenuse. We had this one labeled the O. We had this one labeled the A. I don't remember if I said 33 or 32 actually. But let's label one more side. Let's, like with a number. Let's say that, oh no, let's say we're looking for this one. Okay, so we have a reference angle, we have our hypotenuse, and we're looking for our opposite. So what you have to kind of, you actually just have to kind of stop here and look at SOHCAHTOA and figure out which one we need to use. How do we figure that out? Well, let's go back to our picture. We have the hypotenuse. We don't really care. We're not being asked about this guy, and we don't have a number there, so I'm just going to cross it out. But they want to know the opposite. So we need to go through SOHCAHTOA and figure out which one uses H and O. So sine, oh, right off the bat, we got lucky. So I know that I have to use sine because we're given the H and we're looking for the O. So again, now I'm going to write the full thing out, that the sine of the angle is opposite over hypotenuse. Now that I've written out the general formula for sine, I'm going to plug my numbers in. The angle measure of our triangle is 33. The opposite, when I look over at my picture, that's got a question mark. We don't know what that is, so I'm going to call X. It's really unique, isn't it? The hypotenuse, when I look at our picture, we have that labeled as a measure of 12. So we have a lot of numbers here. We only have one X, so guess what? We can totally solve this. And this may feel really new to you, but how do we evaluate this? If you've ever looked at a calculator and kind of just checked it out, you've probably seen the button that says SIN on it. So you're going to grab a calculator, you're going to press the sign button, you're going to type in 33, and you're going to hit enter. You're going to get this really ugly long decimal, and I'm going to carry it to 4 places because that's kind of like the norm that we do in math. So all I did from here to here was just grab a calculator and let it tell me what the sine of 33 degrees is. Now, again, I still have that X. My goal is to get the X by itself. So I have to look at the 12 and figure out how I need to get it out of there. The 12 is in the bottom of a fraction, so it's actually dividing. To get it out and bring it to the other side, I undo the division. So I'm going to multiply. And if you were going to show your work, which you should do, it'll look like that. Multiplied by 12, they cancel out immediately. What you do to one side of the equation, you also have to do to the other side of the equation. That's the law. I'm sure you've heard that before. So then I'm grabbing my calculator, 0.5446 times 12, hit equals, and nothing fancy, but it comes out to be this. And that is the measure of X, which was this side here. So now I've figured out one of the sides of my triangles. If I wanted to round it up nearest 100, 6.53. Alright, let's try another one. The process is going to be the same. You want to label your triangle, hypotenuse, opposite, adjacent, figure out which trig function to use, and then plug your numbers in and solve. So let me scroll up. And that guy can go too. Fresh start, right? Alright, so this time we have this triangle, and let's say that this guy here is, I don't know, 18 degrees, so we'll say that this guy here is, I'm just making up numbers, we'll say 16 meters, and we're looking for that guy. Okay, first step, we need to find our reference angle and label everything up. So, reference angle, boom, done. Excuse me. Hypotenuse is always opposite the right angle, so I know that's a hypotenuse. The reference angle, if I go straight out from that, that's going to bump into my opposite. And that leaves one more side, which has to be my adjacent. And like a good student, I am going to write out SOHCAHTOA so that I can see it. And now I'm going to figure out which one of these I need to use. So, in our picture, the H doesn't have a number, our hypotenuse doesn't have a number, it doesn't look like we're looking for it, so I'm going to get rid of it. I'm just crossing it out. And then we have the adjacent and the opposite. So let's look across. Sine does not have opposite and adjacent. Don't want it. Cosine does not have opposite and adjacent. Oh, why didn't you guys tell me? Sorry, that should have been an A. That's what happens when you write and talk at the same time. Tangent, opposite, adjacent. Perfect. So, being a teacher, I say go back to the basics, write it out, and then plug numbers in. So tangent of an angle equals opposite over adjacent. Let's see what we have in our picture. Our angle measure is 18. Our opposite, if we go back to the picture, is X. and our adjacent, which we have labeled. And again, labeling it it allows you to not have to think as much in this step. I already have everything labeled. I'm not racking my brain to figure things out. That's why I like to label things. All right, this is going to come out of our calculator. So again, this time you're just pressing the tan button instead of the sign like on the last one. And my degree measure is 18. Again, most of these are going to be pretty ugly decimals. It's just how it is. 0.3249. Again, I need to get the x by itself. Don't let the fractions freak you out, all right? Just conquer them by multiplying. Our task is to multiply by 16 to undo the division. That cancels. What I do to one side of the equation, I have to do to the other side. So let's see, 16 times 0.3249, and that comes out to be 5.1984 equals x. And that's problem is solved. I found the opposite side up here, and if I wanted to round, say to the nearest tenth, let's see, this is the tenth. My 9 will not let it stay a 1. It's going to come up to a 2, so it turns into 5.2. And we have meters for units. All right, I hope this helped. Thank you.